We'll proceed in innovative approach in calculus and we'll see product rule. Integration in calculus, it seems that it always look very difficult. Means differentiation is something that is always crackable. Means I never saw any problem in differentiation. It's pretty easy. Means you can apply chain rule and differentiation is doable. But if you apply integration by part and then while calculating differentiation, chain rule, the equivalent here is integration by part. And if someone is trying integration by part, then step by step, it is becoming complex, complex, complex. If someone applies chain rule, then step by step, it becomes simple, simpler. So, calculating the integral calculus has always been a kind of challenge to people who are involved with the calculus methodology. Integral calculus. There are mainly two forms in integral calculus. One is integration by part or integration by substitution. So integration by substitution, where we talk about system, different coordinate system altogether. That is integration by substitution. But what about integration by part or something like that? So integration by part, actually it falls integration by part, the reverse of integration by part in the differential calculus, it begins from product rule. There is one chain rule in differentiation and there is one product. So chain rule, similar to chain rule, there is integration by part in the integral calculus. Chain rule in differential calculus, something similar in the integral calculus is integration by part. But the integration by part in integral calculus, it has roots in the product rule in the differential calculus. Calculating the differentiation, there is a fundamental of chain rule. These are the two main. Chain rule, chain rule where we see chain rule where we see, then it is kind of the method of substitution in integral calculus. It has a root in chain rule, whereas integration by part in integral calculus, it has a root in the product rule. So how we achieve product rule, and then we will talk about our invention in the product rule. So what is product rule in differential calculus? So consider I have a function called fx. I have one independent variable called x. Okay. So okay, so I have one independent variable called fx. Okay. So I have one independent variable. Okay, so I have one independent variable as fx. So fx is the dependent variable and independent variable is x. X is independent variable and fx is dependent variable. Very clear? So if x is independent variable, fx is dependent variable. Y equal to fx. What is dy by dx? Okay, what is x and fx? So this is x-axis. This is x-axis. And if this is x-axis, then if this is x-axis, this is x-axis, then this is fx. Okay, I mean if this is x-axis, this is origin, this is y-axis, this is fx. What is fx? Now if I say x equal to this, now if I keep it like this, Okay, I mean I can drop it. This is y-axis. Now, if I keep like this and this is x-axis, when x is here, fx is here. When x is here, fx is here. When x is here, fx is here. When x is here, fx is 0. When x is more than that, fx is not defined at all. That is the scenario. At any point x equal to x0 or x equal to x1, what is fx? Or any point on the x-axis, that is x. Then what is the height? What is the height? So height is fx. Is something that function over x. Function over x. Okay. Fx is function over x. If fx is function over x, then this is typically a Python function. Python function takes x as a parameter. Python function take x as parameter and name of the function is f. Now you call f with x as parameter. What it returns is some computation over x. It does some computation over x and returns the net value like sine x. Sine x function over x is sine x. If someone puts x equal to pi by 4, then internally it does sinusoidal computation over pi by 4 and returns, I believe, 1 by a square root of 2, something like that. So fx, so if I have x as independent variable, I can keep changing, I can keep I can keep changing x, and based upon the x, fx would keep changing. So fx is independent and fx is calculation over x. So it is dependent upon x and fx, x and function over x. Okay. Now if I say dfx by dx, dfx by dx, dfx by dx means I am at any point x. At this x, the height is 10. At this x, the fx is 10. Okay, somehow. Okay. Now from here, I moved a little bit away from here. Consider from x. Now another point is x1. Another point is x1. Consider this difference is 1. So x1 is nothing but x plus 1. I am at x. Another point is x plus 1. At x, height is 10. At x plus 1, height is 12. What is dy by dx at x equal to x? What is dy by dx, dfx by dx when x equal to x? X equal to 10. X equal to x. Okay, on x-axis there is a point called x. There is another point called x plus 1. At x, height is 10. At x plus 1, height is 12. What is dy by dx? And on x-axis, x equal to x. So at that point, the x equal to x means what is the value of fx when x equal to x? At that moment, it is 10. What is x plus 1 fx? At that value it is 12. Means if I move 1 point, if I move 1 unit from x, at x the height is 10. At x plus 1 height is 12. Means at any point x, if I move 1 unit, then height is moving by 2 units. So dfx by dx equal to 2. 2 by 1, 2. But not necessarily. Consider I am at any point called x0. Here is x0. At x0, height is 5. At x0 plus 1, height is 8. What is dfx by dx at x equal to x0? Everywhere dfx by dx is not constant. Dfx by dx when x equal to x0. If that is the sense, then when x equal to x0, fx is 5. When x equal to x0 plus 1, fx is 8. So dfx by dx when x equal to x0 is 8 minus 5, that is 3. 3 by 1, 3. So every x, dfx by dx is different. This is differentiation. Differentiation means that if there is 1 unit of change happens on x-axis at any point, then how many unit of change we can see on the fx in accordance with the 1 unit of change. So 1 unit of change, if someone asks, I have fx equal to sine x or whatever, can you tell me dfx by dx? Someone would say cos x, because it is again, no, tell me in numeric value. Then tell me your x in numeric value. Then only I can tell you numeric, because every moment dfx by dx is different. If I draw a sine wave, if I draw a sine wave, typically, if I draw a if I draw a sine wave, then every moment of x, oops, this is sine wave. Okay, first it is going high and then going low. At any moment of x, if I see fx, if I move 1 unit, then how many unit fx is changing? Every moment that change is different. So that's why dfx by dx, d sin x by dx is cos x. Cos x itself is variable. Okay, so resultant is again an algebra because it is variable. Now that is the scene. Then what is dfx into gx? This is the product rule. What is dfx into gx by dx? Generally in book, people find what is product rule? What is the u into v, and in braces derivative? What person will understand? You tell. If a reader is reading what is a product rule in calculus, then u into v and braces close on top of one dash line, that is derivative. Okay, this may be good for PhD. I don't know how many PhD people they also understand calculus. But anyway, now the idea is, if I have fx, that is function over x, and dfx by dx, now we understand. Now there is another function over x called hx. Consider fx is sin x, then hx is cos x. Okay, there is x-axis and there is another function called cos x. So cos x starts at 1, cos x starts at 1 and goes 0 and then negative, and it is like this. It begins at 1, whereas sine begins at 0. That is the difference, and full it goes like this. So there is a function fx equal to sin x. There is a function hx equal to cos x. What is fx into hx? What is differentiation of fx into fx into gx? There is a two function fx and gx. One is sin x and one is cos x. dfx d of in braces multiplication of fx into gx by dx, not by dfx or by dgx, by dx. So if I take multiplication of two functions and try to calculate derivative with respect to an independent component x, multiplication of two functions, one function is a dependent upon x1, other function gx is again dependent upon x only. If I multiply these two functions, derivative of this multiplication with respect to dx, if that is the case, then what it is? That is under question mark. That is fx dgx by dx plus gx dfx by dx. This is product rule. But now it is always a challenge for someone to prove this product rule. There are many ways to prove this product rule. The most basic way that came to anyone try the first derivative. The first derivative is the anyone would try. What is how I can find dfx by dx? That is how I can. So the way I have told, at any point x, what is fx? And if I move 1 unit, consider I move delta x unit, not delta x. Again, this is a problem in calculus book. If I am taking fx at point x, fx means height. If I take fx, this is I am drawing. Anyone can take height or width, whatever. If I am taking fx at point x equal to at point x, and then I am taking going little further and delta x, not delta x. This is the problem. delta x unit, I moved 1 unit in our example. Delta x unit. If I take, if, okay, if I take any point x, then this is the fx. If I move delta x unit, then what is the fx? That is f, that is fx plus delta x actually. So one is fx and one is fx plus delta x. Then what is differentiation? Dfx by dx is nothing but how much fx changed minus how much x changed at point x equal to x. X change delta x by delta x. How much numerator change? That is fx plus delta x minus fx. This is what we did, right? So in earlier example. So dy by dx or dfx by dx is fx plus delta x minus fx divided by delta x, number of units we are taking, that is delta x. This is the basic differentiation. I believe first rule or something different. Now d of fx into gx by dx is nothing but fx plus delta x, fx plus delta x, gx plus delta x minus fx into gx divided by delta x. I believe it is all right. Since it is fx into gx and we are calculating derivative of fx into gx by dx, then it is fx plus delta x into gx plus delta x minus fx into gx divided by delta x. Now x plus delta x, fx plus delta x, gx plus delta x. Okay, that is the scenario. Now consider I introduce something called gx, okay, g gx plus delta x. Now I introduce something called gx plus delta x into fx, gx plus delta x into fx. If I introduce like this, gx plus delta x into fx, then I have to introduce another one minus gx plus delta x into fx. So I am introducing gx plus, so now it is fx plus delta x, gx plus delta x minus fx gx by delta x. On numerator, I am adding gx plus delta x into fx minus gx plus delta x into fx. If that is the case, then gx plus delta x come outside and fx plus delta x gx plus delta x plus gx plus delta x fx minus gx plus delta x dx plus delta x fx. This is introduced and then minus fx gx. Now minus gx plus delta x into fx, I can take left side and plus I can keep right side. So left side it becomes fx plus delta x gx plus delta x minus gx plus delta x fx. So gx plus delta x comes outside and fx plus delta x minus fx and divide by delta x anyway we have. That transform into gx plus delta x dfx by dx. Gx plus delta x dfx by dx. Now, what is left over? That is plus gx plus delta x fx, gx plus delta x fx minus fx gx. So there fx I can take outside and it becomes gx plus delta x minus gx by delta x. So it becomes gx plus delta x dfx by dx plus fx d gx by dx. So product rule is the multiplication of fx and gx. If I go with the differentiation of multiplication of fx and gx, dfx gx by dx is nothing but gx plus delta x dfx by dx plus fx dgx by dx. Now x plus delta x. Now delta x is, this is what I don't like in mathematics. That infinitesimally small, if we take, then we can consider it at zero. But anyway, this is not my fundamental. So anyway, if I take delta x as 0, because it is very small, then it becomes g. Otherwise, this proof is error proof. Then it is gx dfx by dx plus fx dgx by dx. This is the first principle. This is the proof of the product rule. Product rule means differentiation of fx into gx if fx is gx differentiation of fx plus fx differentiation of gx. Okay, that is the concept. Or fx differentiation of gx plus gx differentiation of fx. This is product rule, and one of most precious, I would say, the most precious thing in the differential calculus, precious than chain rule also. This is product rule. Now if product rule is ready, what is the differentiation of sin x into cos x? So first I have to keep sin x and then differentiation of cos x. So sin x into minus sin x plus sin x into minus sin x plus I have to keep cos x outside and then differentiation of sin x, cos x. So it becomes cos square x minus sin square x. That is differentiation of sin x, cos x. Okay, pretty simple, right? What is differentiation of tan x? Tan x is sin x by cos x. If that is true, then fx is sin x and gx is 1 by cos x. Cos x to the power minus 1. So actually we are trying to find differentiation of tan x. We are trying to find differentiation of sin x into cos x to the power minus 1. This is what we are trying to find. So sin x we will keep outside and differentiation of cos to the power minus 1. That is minus 1 cos to the power minus 2. That is sin x minus sin x. Oh, I'm sorry. Sin x I keep and differentiation of cos to the power minus 1. So if I differentiate with the chain rule, with first with respect to with cos x, then it is minus 1 by cos square x. Then again differentiating cos x with the x, then it becomes minus sin x, minus minus plus sin square x by cos square x, plus cos to the power minus 1 I'll keep outside, and then differentiation of sin x, that is cos x. Cos x and cos inverse x gone, 1 plus 1. So sin square x by cos square x plus 1, that is sin square x plus cos square x by cos square x, that is 1 by cos square x, that is sec square x. So the differentiation of tan x is sec square x. Pretty simple, right? Anyone can find anything. Product rule is very precious, very precious. Amazingly precious is the product rule. Chain rule is simple, right? Chain rule is simple, simple differentiation. What is 10 by 2? What is that? Is the chain rule, right? What is 10 by 2? I don't know what is 10 by 2. 10 by 2. 10, what is 10 by 2? Okay. So ask someone, he say, I don't know what is 10 by 2. You know 10 by 5. Yes, I know 10 by 5 is 2. Simple, right? 10 and 5, 2. Okay. You know what is 5 by 2? Yeah, 5 and 2, that are, they are again near to each other. So it is 2.5. And the same thing, 10 by 5 into 5 by 2. That is chain rule. So 2 into 2.5 is 5. Okay, so 10 is a big term, 2 is a small term. It is difficult to do the kind of division. So 10 by 5 into 5 by 2. Same thing is chain rule. The differentiation of cos to the power minus 1, first differentiate with cos x only, then minus 1 cos to the power minus 2. Then differentiate with cos x with the x, that is minus sin x. So chain rule is simple division only, but product rule is not simple division, simple multiplication. Product rule of 3 into 5 is not something that we calculate differentiation here and there. So product rule is the most precious thing as far as differential calculus is concerned. So one way, that is the first principle, we have calculated the first product rule, but locha is that gx plus delta x into dfx by dx plus fx into dgx by dx. This is what we calculated. And x plus delta x we muted. At the end we muted delta x. This is the way we proved it. What is the other way to prove the product rule in calculus? There is one thing called area rule. Area rule. That is gx into fx. I need to find differential of gx into fx, right? Gx is a function over x. Fx is a function over x. Now consider that since it is gx into fx, it is multiplication gx into fx or fx into gx. But if there is multiplication of two items, what is 10 into 20? What is 10 into 20? Okay, 10 into 20. Then if I take a rectangle whose width is 10 and height is 20, then is area of rectangle is 20 into 10. I don't know that much also. What is 10 into 20? I don't know. Okay, you're talking about area of the rectangle is length into length, width into length, or width into height, whatever it is. So calculate the area of the rectangle where width is 10 and height is 20. That is what the multiplication is. Okay, I am not that much literate. What I would do is I'll take a kind of a square shape some item whose length is 1 and width is 1. One square kind of thing. Now I here on the width wise I'll arrange 10 because width is 10, right? So 10 items I would arrange. Now height is 20. So 20 item I would arrange. 20 items, then 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 20 items. This is 10 item by 20 item. Now calculate the area. Area is nothing but just count it how many there are. So 10 plus 10 plus 10, or just count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will become as 200. So multiplication is nothing but area of a rectangle whose width is one item of multiplication and height is another item of the multiplication. Okay, that is the multiplication. Now if I want to calculate the differentiation of fx into gx, then I would consider then I would consider, okay, one rectangle whose width is fx and height is gx. Now at the end, fx into gx is the area. This area where fx is a function, fx is not x-axis, fx is a function over x. If I draw fx with x, then x is x-axis and fx is like this. Gx is function over x. If I draw like this, then this is x, then this is gx. Fx into gx. Okay, so this fx into gx constitute an area of a rectangle where width is fx, height is gx. Now if I differentiate with x, then how differentiation means how much change it brings. I believe it's all right. Okay, now consider that this is x-axis. Consider this is x-axis and y-axis is fx into gx. Possible, right? If this is x-axis, y-axis is fx, this is x-axis, y-axis is gx. I don't have any shame in saying that this is x, then y-axis is fx into gx. Y-axis is not a length, y-axis is area, where the x-axis is length. X-axis is length and y-axis is area. What we are trying to do? We are trying to calculate d area by dx. If I move, so this is area curve. The curve what I see with x and fx into gx is the area curve. Okay, this is the area curve where each height is fx into gx. At any point x, what is fx into gx? And if I move delta x unit, then what is fx into gx? Now decrement that at del x plus delta x, what is fx into gx? or fx plus delta x into gx plus delta x. And at x, what is fx into dx? Subtract it, divide it by delta x. Means if I make 1 unit of change along x-axis in x at point x, how many unit of change that is happening in the area? D area by dx. Consider the change in area. Change with 1 unit change in x brings delta A area change. Okay, where this now, like, go back for the area of the rectangle. One rectangle a line is fx, one is gx. Now this is a rectangle. If there is 1 unit change in the x-axis, x and fx gx graph I drew, then it brings delta a unit change. How delta a would be adjusted? If there is a delta, this is again wrong in the book, where they consider that this is area, then the delta change will be bigger area. Okay, that is not the case. I mean, it can be solved without diagram also. If d fxy by dx is d area by dx, means if there is a unit change in x, it brings delta a change in fx into gx. Now delta A would be contributed, would be shared by fx and gx. Now delta A means it brings delta delta f delta f change in fx, and delta g is change in gx. Means delta f into delta g is delta A. If there is a delta A change because of 1 unit change in x, delta A change can be attributed to individually to fx and gx. For fx, consider it changed by delta f. That is the share of fx in delta A, and share of g in delta A is delta g. If that is the case, then if this is fx and this is gx, okay, this is gx, then the consider this is the change that is seen here, and that is the earlier, okay, fx is up to here and gx is up to here. In fx, this is the little bit change that happened because there was delta A, and gx little bit change here, it happened because of delta A. Now this change, if I take this strip up to here, what is area of that strip plus what is the change if it contributed here, what is the area? This is the delta A actually change from here to here, and then from here to here. So here the change in the area is gx, gx into delta f, gx into delta f, and here the change in the area is f into delta g. So net delta A is gx into dfxy by dx, that is delta f, plus fx delta g dgxy by dx. We proved it. Okay, so dfx into gx by dx, the change in multiplication of functions, two functions, not variable. Variable is x1. Multiplication of two functions with respect to one independent variable over which those are the functions. Dx equal to, again, that one area, that change in area. So if this is what we are saying, then this is nothing but with respect to delta x change in x, how much delta change in area it contributes, it is delta A. Now delta A, if area is gx into fx, delta A will have share in gx and fx. For fx, share is delta f, and for gx, share is delta g. And if this is fx, then delta f is this one. If this is gx, then delta g is this one. If that is the case, then this area that got introduced new, that is gx into delta f, and this area that got introduced, that is fx into delta g. So f into delta g plus g into delta f is the net area got changed. So that is the differentiation. G dfx by dx plus fx dgx by dx. Okay, so we will see, it is really interesting and mind blowing, and it would be kind of supportive. So someone would kind of someone would praise it, someone would support it from backside if someone proceed on this with other way of calculating the product, because it is motivating. So it is a motivation for anyone to proceed in product rule, how much he can proceed, because this way it would be more insight into the calculus. He would understand the calculus more in a generic fashion, more in a graphical fashion. Please do support us, because all explanations are ours only. Even though these are available in the book, but all explanations are ours only. So our phone number is +91 is the India country code 94831 60610. +91 is the India country code. Telephone number is 94831 60610.